Assalamu alaikum dear students, hope you are doing well by the grace of Almighty. Welcome to our NIEVS Home School. This is Marjia Islam, Assistant Teacher of Science, National Ideal English Version School, morning shift. Now I am going to take a physics class for class 9, our lecture number 3, SW number 2. Our today's topic is chapter 1, reading done, part 3. Now start our class. Our today's topic is measuring instrument. Once it was very difficult to measure different quantities of physics accurately, the job has become much easier due to electronics based instrument for the physics that we will try to learn in this book. Knowing how to measure distance, mass, time, temperature, electric current and voltage will be enough. Let us discuss what type of instrument we will use to measure this. Now this is scale. A meter scale is used to measure small lengths, and definitely you may have seen it, since this is 100 centimeter or 1 meter long. It is called a meter scale. Since in many places inch foot is familiar still now, USA is an example. Inch is marked very often on the other side of a meter scale. 1 inch equals to 2.5 centimeter. Dear students, underline this line. This is very important. 1 inch equals 2.54 centimeters. We can measure up to the smallest division on a scale. A meter scale is generally divided up to millimeter. I repeat, we can measure up to the smallest division on a scale. A meter scale is generally divided up to millimeter. So using a meter scale, we can measure the length or anything up to millimeter. Therefore, if we say the length of anything is 0.364 meter, this means the length of this is 36 centimeter and 4 millimeter. Using a meter scale, it is not possible to measure lengths smaller than this. That is, generally we can never say the length of a body is 0.3643 meter, but from time to time, for microscopic purposes, we have to measure the smallest length of objects of this type, which can be performed by using an interesting scale called Vernier scale. I repeat, what is Vernier scale? The smallest length of object of this type, which can be performed by using an interesting scale called Vernier scale. Now go to our topic is Vernier scale. Let us consider that the length of an object comes in between 4 and 5 millimeter, marking the length of the object is greater than 4 millimeter and less than 5 millimeter. We can use the Vernier scale to find how much fraction is greater than 4 millimeter. This scale is attached to the main scale and can be moved forward and backward. I repeat, this scale is attached to the main scale and can be moved forward and backward. In the example shown in the figure, the length 9 millimeter of the main scale is divided into 10 division on the Vernier scale. Therefore, every division of the Vernier scale equals 9 by 10 millimeter, less than a millimeter by 1 by 10 millimeter. If the initial mark of the Vernier scale coincides with any mark of the millimeter scale, then the next mark of the Vernier scale will keep a separation of 1 by 10 millimeter from the actual millimeter mark, and the next will keep a separation of 2 by 10 millimeter, third one will keep a separation of 3 by 10 millimeter, and so on. Now go to the next page. Therefore no mark of the Vernier scale will coincide with the millimeter mark of the main scale. Finally, the 10th mark will coincide again with the 9th millimeter mark of the main scale. Students, look at the picture. Main scale, movable, Vernier scale. Here, this is the main scale and this is the Vernier scale. This Vernier scale is movable. This is Vernier scale, this is main scale. If we keep the Vernier scale in such a way that it does not start from a millimeter mark, rather it starts with slides 3 by 10 millimeter displacement, then the number of 1 by 10 millimeter displacement by which it has moved will be the mark of the vernier scale coinciding with the millimeter mark of the main scale. Therefore, the difference between one division of vernier scale and one division of the main scale, this is called Vernier constant. I repeat, what is Vernier constant? The Vernier constant is the difference between one division of vernier scale and one division of main scale. This is called the Vernier constant. In brief, VC, this is Vernier constant. This can be calculated if we divide the length of the smallest division 1 mm of the main scale by the total number of division of the vernier scale. In this figure, in our example, the value of this Vernier constant 1 mm divided by 10, we get 0.1 millimeter. Now it is converted millimeter to meter, then we get the answer 0.0001 meter. Now to measure a length, we have to look at the vernier scale after measuring up to the last millimeter mark. The mark of the vernier scale that coincides exactly with any millimeter mark of the main scale is then found, and then that number is multiplied by the Vernier constant. We will get the actual length by adding this amount with the length measured by main scale. This is the part, actually our practical part. We will learn more about this topic in our practical laboratory. We will get the actual length by adding this amount with the length measured by main scale. According to our procedure, the length shown on the last scale of the figure 1.06 is 1.03 centimeter or 0.013 meter. Now go to the next page. Instead of the vernier scale, we can use a special type of scale called a screw gauge. This is called screw gauge. Instead of vernier scale, we used this screw gauge to measure length. In a screw gauge, when the screw rotates, the scale moves forward or backward. The threads of the screw are kept very fine. After a complete rotation of the screw with the attached scale may advance by 1 mm. This displacement of the screw is called the pinch of the screw. I repeat, after a complete rotation of the screw with the attached scale may advance by 1 mm. This displacement of the screw is called the pitch of the screw. The circular part of the instrument, by the rotation of which the screw moves forward or backward, is divided into 100 equal parts. For the rotation of only one division of the circular scale, the screw advances by 1/100 of the pitches. Therefore, this scale up to 1/10 mm equal to 0.01 mm of the length measurement is possible. This is called least count of the screw gauge. I repeat, this is called the least count of the screw gauge. This is the picture of slide calipers. This is the picture of screw gauge. This is the balance you read out at your home. This is the balance. Digital weight machine. This is digital weight machine. This is stopwatch. Now go to the next topic. This is making slide calipers. My dear students, I have made this. My dear students, this is slide calipers. Making slide calipers with papers. My dear students, I have made this for you. You will try at your home following this procedure. This is this procedure. Follow this procedure. Now we go to the next topic. This is important for our practical. This is the practical part we will do in our laboratory, in our practical classes. Now error and accuracy. This is the topic. Now this is the topic. Now we go to move forward. Here is a relative error. This is the formula. This is absolute error divided by measured error. Using this formula, we will solve our mathematical problem. This is a mathematical problem. This is our solution. Now we do this math. Our mathematical problem is, suppose you have got 10 centimeter by measuring the length of a square shape book. Suppose the relative error in the measurement is 10%. What is the relative error in its area? Now go to the solution. Our solution is, measured area of the object is 10 centimeter into 10 centimeter equal to 100 centimeter square. We know this is the length, and when we measured area of the object, then length into length, and finally we got the area. This area is measured area. Since the relative error of the object is 10%, hence if its length is measured, the minimum length will be 9 centimeter and maximum length will be 11 centimeter. Our measured value is 10 centimeter. Our minimum length will be 9 centimeter and our maximum length will be 10 centimeter. Then we find the minimum area. Minimum area 9 into 9 centimeter into 9 centimeter, then we get 81 centimeter square. This is the minimum area, and maximum area, maximum length 11 centimeter, then maximum area 11 centimeter into 11 centimeter, then we get 121 centimeter square. Therefore, the absolute error, the absolute value 100 centimeter square subtract 81 centimeter square, then we get 19 centimeter square. This is the wrong information. Right, this is 100 centimeter square subtract 81 centimeter square, then we subtract, we get 19 centimeter square. 19 centimeter square, this is centimeter square, and 120, our highest maximum area 121 centimeter square, subtract our measured area 100 centimeter square, then subtract this, we get 21 centimeter square. Then since the value are not equal, this value 19 centimeter square and this value 21 centimeter square, these values are not equal, we consider the larger one. That's why we take the value 21 centimeter square. The absolute error is 21 centimeter square. Therefore, now we use this formula, relative error equal to absolute error by measured error. Therefore, the relative error equal to 21. This error 21 centimeter square divided by 100 centimeter square. Then we get a result 0.21. In percentage, we multiply 100, then we get a percentage result. Our result is 21 centimeter. Our result is 21 centimeter. If the error in the measurement of the length is 10%, then in the case of area, it will be approximately double. Similarly, you can show that in the case of the volume measurements, the error will be 3 times. Now, our next question, next problem is, you have measured a box by a ruler which is graduated only in centimeter. You have got the length, breadth and height of the boxes as 10 centimeter, 5 centimeter and 4 centimeter respectively. What is the percentage of error in your measurements? Now we go to the solution. Our answer is, since your ruler is graduated only in centimeter, so your error is plus minus 0.5 centimeter. Therefore, the error in your measurements, this is length. Our actual length is 10 centimeter. Then we added plus minus 0.5 centimeter error. Then we get the length is 10 plus minus 0.5 centimeter. And now the next one, breadth. Our actual breadth is 5 centimeter. Then we add error is plus minus 5 centimeter. Finally, we get the breadth 5 plus minus 0.5 centimeter, and our next one is height. Our actual height is 4 centimeter. Then we add plus minus error 0.5 centimeter. Then we find our height 4 plus minus 0.5 centimeter. You measured volume. Our actual volume, our actual length is 10 centimeter. Actual breadth is 5 centimeter. Actual height is 4 centimeter. Then you measured volume, actual length, actual breadth, actual height. This is 200 centimeter cube. Now probable smallest volume, probable smallest, that means we count negative 0.5, negative 0.5 centimeter. Then length is 10 minus 0.5 centimeter. This is length because we count the negative one for smallest volume. Then our length is 10 minus 0.5 centimeter and our breadth is 5 minus 0.5 centimeter because we consider negative value because of smallest volume, and height 4 minus 0.5 centimeter. We consider here the negative value because of the probable smallest volume. Then this is the smallest length 10 minus 0.5 centimeter. This is the smallest breadth 5 minus 0.5 centimeter. This is the smallest height 4 minus 0.5 centimeter. Now we calculate this, we get 149.625 centimeter cube. We go to the next, probable largest value. The largest value, when we consider positive 0.5 centimeter, then we get a length 10 plus 0.5 centimeter. Then we get a breadth 5 plus 0.5 centimeter and 4 plus 0.5 centimeter. Now we multiply this. This is length, this is breadth, this is the largest length, this is the largest length, this is the largest breadth, this is the largest height. Then we multiply this, length into breadth into height, for getting volume, probable largest volume. Our probable largest volume, after calculating this, we get 259.875 centimeter cube. Therefore the volume is 149.625 centimeter cube, greater than volume less than 259.875 centimeter cube. Now we calculate the absolute error. This is our relative error formula. Now our absolute error is from 149.625 centimeter cube to 200 centimeter cube is, this is the subtraction, 200 centimeter cube subtract 149.625 centimeter cube. Our result is 50.375 centimeter cube. Now from 20 centimeter cube to 259.875 centimeter cube is, this is the subtraction. We subtract 259.875 centimeter cube minus 200 centimeter cube. Our result is 59.875 centimeter cube. Now considering the largest value, we have the absolute error 59.875 centimeter cube. We consider the largest one, that's why we take 59.875 centimeter cube. Sorry. Now we use this relative error formula. The relative error formula is absolute error by measured value. Here the relative error, our absolute error value is 59.875 centimeter cube and our measured value is, this is our measured value. Our measured value is 200 centimeter cube. If we get the result in percentage, then we multiply 100. Then we get the answer 29.9375%. It is approximately 30%. So my dear students, our today's SW number 2, our SW number 2 is this math, only this math, our SW2, math nong 1. This is our 1 nong math, this is our 2 nong math. Your homework is 1 nong math. this is your homework. My dear students, hope hope you have understood today's topic. See you again in the next class. Till then, Allah Hafiz.